No, I'm sorry. They're just second and quit. Get out of there. Please wake up. Like, wow, wake up. What is going on? Okay, perfect. Parentheses around the numerator, left parenthesis. Then we have -6. The operational negative, the symbol negative, not the operational negative. We have to start with this negative, the small one. -6 plus the square root. Put parentheses under the square root. It already pops up with parentheses. Do not put second set of parentheses. So we have 36 plus 4 times 4. I can multiply that. It's 16 times 7. Close the parenthesis under the square root. And then go outside and close the parenthesis. And then divide the whole thing by 8 and press enter. And this is our first solution. That is an approximation. I'm going to go back and show you how to simplify and get the exact answer also. But in case we need an approximation, I wanted to show you how to put in the graphing calculator. So plus the square root. Okay, 36 plus 16 times 7. Close the parenthesis. Close the parenthesis for the numerator. And divide by 8. And now when we want to repeat the entry, we go to second and entry, copies everything. All you have to do now is overwrite the plus by the operation of minus and press enter. You get the other solution in a blink. And I'm going to do the same thing here. So second and entry, you will copy everything you have. For me, it's more difficult than for you with the calculator. I have to go back and override the plus. And yes, of course, it goes all the way. Okay, minus here. And I got the other solution. So the approximations are x1, the first solution, approximately 0.77, and x2, approximately -2.27. But now let's say that the problem is asking us to determine the exact solutions. Okay, in that case, I only need to multiply the 36 and add, 36 plus 16 times 7, and I got 148. Okay, so the exact -6 plus or minus the square root of 148 divided by 8. I have to simplify the square root of 148. See what it has. So 148, it's an even number, so it's divisible by 2, so then I get 74. 74 is divisible by 2, so I get 37, so I have to stop. So then x equals -6 plus or minus, this is 4, the square root of 4 is 2, let me write it like that, and divided by 8. So then from here I have x equals -6 plus or minus 2, the square root of 37, divided by 8. So I have to simplify it. Do not cross a 2 with an 8 or 6 with an 8. You cannot do that. You have to separate -6 over 8 plus or minus 2, the square root of 37 over 8. Now you can simplify. I'll simplify by 2, -3/4. I'll simplify by 2, the square root of 37 over 4. And this is the exact. These are approximate. They're approximate solutions. These are the exact solutions. Any questions? Any questions on the quadratic formula? Would you like to choose another? Yes, please, Maureen. It depends on the problem. So if the problem is a word problem and you ask me how much money I have in my pocket, I'm not going to say -3/4 plus or minus the square root of 37 over 4. I'll tell you the amount, so I have to approximate. If we're talking about the distance, if we're talking about height, then I have to approximate. But in certain situations, we will be asked to find the exact answer, and we have to present this. It depends on the problem. Yeah, I completely understand. Very good question. Okay, so solving quadratic equations. We know 3 methods already. And you can say, do we need the 4th one? Yes. But I'll tell you something about the 4th one in a minute. Factoring. That's why we reviewed everything. Number 2, taking square roots. When do I do this? When do I use taking square roots? Only when I have something like this. If I don't have something like this, I will not use taking square roots. Only if it looks like this. If the equation looks like this, then yes. The 3rd method doesn't matter. Quadratic formula. But remember, you have to have a squared plus bx plus c equals 0 in this format. Not c on the other side or bx on the other side. It has to be in descending order so you can apply quadratic formula. The 4th one is called completing the square. I have to be honest with you. If you give me a quadratic function, if you give me a quadratic equation to solve, if it looks like this, I will take the square root. If it's easy to factor, I will factor. But if it takes me 5 minutes to factor, forget it. I'm going to use the quadratic formula. When will I ever use this? The answer is never. And then why? Why do we even study it here? It's useful for something else in the next course. That's why we study it here. But I will never consider it myself as a method of solving a quadratic equation, ever. Unless you specify you have no choice. You must use this method. Otherwise, I will never use it. So one more time. If I'm given a quadratic equation to solve, and if it's in this format, I will take the square root immediately and I'm done. If it's not in this format, I'll try factoring. If it takes more than a minute, I'll say forget it, and I'll use the quadratic formula. Only if you force me and you say this particular equation has to be solved using completing the square, then I have no choice. Otherwise, I will never think of this. Okay. So now let's see what it is. So let's say we have the equation x squared minus 4x plus 1 equals 0. And let's say I am specifically asked to use the completing the square method. Okay. What does that mean? It means that I have to do something to this to make it look like this. Something with x squared and a number on the other side. And then you'll say, fine. So after you work so hard, you change this into that, then what? Then you have to use taking square roots. So for 2 reasons, I will never use this completing the square method. Number 1, it alone cannot solve the equation. You are changing the equation into this, and then you apply taking square roots. Secondly, it's too long of a method, and I have the other 3 that do the perfect job for me. But again, we need to study this for something else in the next course. Okay, so let's do it. First of all, as the beginning, I would recommend if you see a free term like this one, this is a free term, it doesn't have x, move it to the other side. And then we have x squared minus 4x equals negative 1. Now, looking at the left-hand side, can anyone identify the middle coefficient of this? So it's not this coefficient and it's not this coefficient. The middle one must be negative 4. So we always read a number with a sign in front of it. So step 1, middle coefficient is negative 4. In step 2, divide it by 2. When I divide negative 4 by 2, what do I get? Very good. Negative 2. Right. Step 3. Square negative 2. When I square negative 2, what do I get? 4. Very good, right? There is no doubt there, right? Negative 2 squared is 4, correct? Good. Step 3. Step 4. Add 4 to both sides of the equation. So I'm copying the equation here one more time. I'm going to add 4 to this side and 4 to this side. Am I allowed to add 4 to both sides of an equation? I'm sorry? It was negative 1, yes. Thank you. Thank you. Good. Can I add 4 to both sides of an equation? Am I allowed to? Will I change the solutions? So what do you think? Am I allowed to add 4 to both sides of any equation? Of course. Will I change the solutions? No. The balance is still balanced. Okay. So now the left-hand side becomes this, and the right-hand side becomes this. And now you will tell me what this represents. That's the reason why I asked to stop foiling those binomials squared, and then we'll have difficulties later.
Looks like the A and B.
Right, but I have to factor it. How do I factor that? The trinomial in descending order, no greatest common factor, no negative leading coefficient, special product. Which one? Special product. There are 2 special products. Look at that. There are 2 special products for trinomials. It's the column in the middle. There are 2 special products for trinomials. Which one is it? Good. So tell me what to write. Right, but for this one, apply that for this and tell me what to write. Indeed, that is the one. It has to be a binomial squared. We know that. The binomial squared is 3 terms. Of course. So after all this work, we managed to complete the square. We haven't solved the equation. What do I have to do now? Yes, indeed, I have to take the square root, and I get x minus 2 equals plus or minus the square root of 3, and I have to move 2. So as you see, it's a long process, and it doesn't really solve the equation. I have to employ a different method of solving quadratic equations, which is taking square roots from both sides. Okay, let's take a look at another. Let's say x squared plus 6x plus 7 equals 0. First step. Say it again. I agree. X squared plus 6x equals negative 7. Very good. Middle coefficient. Divide that by 2. Square that number. Very good. That's it. It has to be on both sides. If we don't put it on both sides, then we do change the equation. Can anyone tell us what is on the left? I'll tell you what's on the right, which is 2. Please tell me what we have on the left.
Is it X plus B squared?
Very good. It's what I squared to get 9. Excellent. Now we take the square root. We have x plus 3 equals plus or minus the square root of 2, or x equals negative 3 plus or minus the square root of 2. So initially it looked kind of difficult, but it's really not. But it's cumbersome, and we cannot solve the equation. Simply completing the square does not solve the equation. You have to use taking square roots to finally get those solutions. Any questions for me?
You have to put the negative front.
Say it again.
You have to put the negative.
Very good question. Yes, we don't really like to put anything behind the square root because we may accidentally extend the square root on top of it. Very good question. Thank you for saying that, Maureen. Is that clear? Yeah. So, and of course, you cannot put the number between the plus and minus. These are together, right? So the only option is to either put it in front or put it at the end. We don't want to put anything behind the radical if we can avoid it. Sometimes we can't avoid it. Very good question. Thank you. Any questions? The last topic before we start reviewing on Monday, and then we decided then to have the test the following Monday.
After Thanksgiving.
Yes.
Yes, that's what we decided.
Okay. So then the entire time on Monday and the entire time on Wednesday we're going to review for this test. Okay? Okay, perfect. So the last topic that we have to look at is graphing quadratic functions. Graphing quadratic functions. When we graph a linear function, what do we graph? What is the graph of a linear function? How does it look like? Is it a circle? What is it? A straight line. Awesome. Do we know how a quadratic function looks like? Yes, we graph that, right? In transformations, remember the x squared? Yes, perfect. So there are two forms, right, of the quadratic function. We can be given the quadratic function as a x squared plus bx plus c. This is one option. And here's the second option, the second form, x minus h squared plus k. We're going to talk about this after we talk about the first one. So don't even, we use transformations. That's the second one uses transformations. So we've seen the second one, but I want to start with the first one. So here's an example. I'll make one up. So let's say f of x squared minus 6x plus 8. Is this a quadratic function? Is this a quadratic function? Of course. Very good. So can anyone give us the leading coefficient? 1. Very good. Which is a number greater than 0. The quadratic function has two possibilities. This is one with a minimum, and this is one with a maximum. So this one has here this point, which is a minimum, and this one has this point, which is a maximum. They are both, of course, first of all, they are called parabolas. So the parabola is the graph of a quadratic function. A straight line is the graph of a linear function. And they are symmetric. This is the line that is the axis of symmetry. Axis of symmetry. So min and max, they're also called vertex. So this point is called vertex as well as this one, vertex. The first situation is when a is a positive number. The leading coefficient is positive. The second one for a maximum, the leading coefficient is negative. Since you told me that a, the leading coefficient is 1, then we know that the parabola will have a minimum. So this is our case. I'm going to write yes for this one. This is just by comparison, but this is not our case. In number 2, we want to find the vertex. So in number 1, we identify the shape. whether it's opening upward and has a minimum or opening downward and has a maximum. The next we have to find the vertex. And here are the coordinates of the vertex. Let's go back to the quadratic formula for a moment. First, I would like to connect the concept so you can easily remember. The x-coordinate of the vertex is this, negative b over 2a. So everything from the quadratic formula except the square root with a plus or minus, negative b over 2a. So negative b over 2a. Now the question is, how do I find, let's determine this first. Can anyone, remember you have to write that minus, can anyone give us the b? Careful. We always take the numbers with the sign in front. We cannot separate them from the sign in front. This is the sign from the formula. It has nothing to do with that. I'm asking about b. Negative 6, very good. And 2 times a. How much is 2 times a? How much is a? How much is 2 times 1? 2. So then the answer is, remember this is from the formula that you cannot change. So this is positive 3. So the vertex has 3 as the x-coordinate. Yes. There are 2 negatives in there, so that makes a positive. Yes, this sign comes from the formula. You cannot change that. That's carved in stone. And this is a negative 6 because that's what b is. Good. So now I have x, which is 3. Can you tell me how will I determine the y-coordinate? So I have x, and I want to determine the y-coordinate. How do I do that? How do I determine? So for any function, if I say, Maureen, I'm giving you 3 for x, find y. What would you do with that to find the y-coordinate? What do you think? I'm giving you the function, and I'm saying x is 3. How do you find the y-coordinate? Say it again. You plug it in, right?
Oh, it's in the equation.
It's the function, exactly, right?
Oh, yeah.
So this will be f of 3. So then this is f of this number, negative b over 2a. That's it, right? So if I'm giving you the function, I say x is 3, find the y, you're going to find f of 3, correct?
You don't put into the mean.
So this number is 3.
Okay.
How do I find the y-coordinate?
I know you're going to plug in 3, but you plug into
The only function I have. The only function I have. X squared minus 6. I don't have another function. That's all I have. So this is the function that I'm going through several steps to graph it. So then finding f of 3 will be 9 minus 18 plus 8, which is negative 1. So I determine the coordinates of the vertex. In the next step, which is step 3, I find the x-intercepts, something very important now, comma, if they exist. What does this mean, if they exist? So the function has a minimum or a maximum. One more time. The function has a minimum or a maximum. Minimum, very good. So if it has a minimum, right, it looks like this. Agreed? How many options are for a function like this? 3 options. So let's look at those 3 options. One option is this. Second option is this. And the third option is this. Let's analyze this. How many x-intercepts does the first one have? None. How many x-intercepts does the second one have?
2.
Distinct. Different, right? Excellent. How many x-intercepts does the last one have? Right. It's the same one at the same point. Right. The 2, but at the same point. 1 point. Good. This one, our function has a minimum at 3, and the minimum value is how much? When x equals 3, there is a minimum. How much is the minimum? Right. What do you think? Is it the first case? Is it the second case? Or is it the third case? Of course, because the minimum value is exactly. So in our case, I'll say no, and I'll say yes. So now I'm asking you, should I waste my time, spend my time on finding the x-intercepts? Do they exist? They exist. So I have to find them. How do I find the x-intercepts for any function, including this one? Excellent. So x squared minus 6x plus 8 equals 0. I have 4 methods of solving quadratic equations now. Which of these 4 would you use? Would you complete the square? Will you complete the square? Absolutely not. From the other remaining 3, will you take the square root? No, it's not ready. It's not ready for taking square roots. So then I'm down to 2. Which are those 2? Factor or quadratic formula. Of course I'll try factoring. If it takes more than 30 seconds, then I'll use the quadratic formula. But not taking square roots because it's not ready, and of course I'm not going to complete the square. So can you factor quickly for me? If you can factor quickly, then we have to use the quadratic formula. Which one is it? Wake up, wake up, wake up. I know it's the end of the semester. I know everyone is tired. Very good. -2 and -4. So we have 2 options, 2 and 4. So can anyone give us the x-intercepts now? The x-intercepts are? Say it again. Yes? Yes? 4? That's it. Okay, number 4. Y-intercept. This will always exist. I don't have to write comma if it exists. It will always exist. How do I find the y-intercept for any function, including this one? Very good. F of 0. 0, 0. What is it? Zero, 0. What is the y-intercept? Very good. So then, in ordered pair format. Very good, awesome. Can anyone, without even graphing it, we know the range of this function. Can anyone give us the range? What is the minimum? What is the minimum? We just determined the minimum a minute ago. -1. Right? We determined the vertex. 3, -1. And it opens up. So what will be the range? From 2? Of course, of course. -1 to infinity. Number 6, axis of symmetry. What is the axis of symmetry? And number 7, minimum, we already gave it to me. Mean value is -1. What is the axis of symmetry? So we have the vertex, which is 3, -1. Can anyone give us the equation of the line passing through the point 3, -1? The vertical line passing through 3 comma negative 1. What line is that?
Is it Y?
It cannot be y if it's vertical. If you want to talk about the minimum, you can say y equals negative 1, but we are interested in the axis of symmetry. It has nothing to do with y if it's a vertical line. X equals?
3.
Exactly. So the axis of symmetry is x equals 3. That's it. We have everything we need to graph this function. Ready? We start with the vertex. Can anyone give us the vertex one more time? The vertex is a point. It cannot just have y without x. I can plot negative 1. So what are the coordinates of the vertex? It's right here. Right? 3, negative 1. Then we draw the axis of symmetry. Then we plot the x and y intercepts. You gave me 2, 0, 4, 0. You realize that these have to be symmetric with respect to the axis of symmetry. And then you said the y-intercept is 0, 8. 1, 2, 3, 4, 5, 6, 7, 8. And here's the graph. Make it as symmetric as possible and not too acute at the vertex. Is my graph perfect? No. Cannot be. So we determine the vertex way before we graph the function. The range way before we graph the function because we knew it has a minimum. The minimum value was negative 1, and it opened upward, of course. Is it clear why the range is negative 1 to infinity? Any questions? Any questions? Should we look at another example like this, or should we look at the other one that we already seen before with transformations? It's up to you. We have about 7 minutes left, so we can work on another problem like this, or we can work on the final one. The final one? Okay, very good. So let's take a look at another example. This should be easier than what we've just seen. So let's take a look. Let's say negative x plus 2 squared and plus 4. Thinking about transformations. X squared is the base function. Where do we shift this graph? Do we shift it to the left 2 or to the right 2? Excellent. So imagine that I'm starting with x squared at 0. You told me 2 to your left, perfect. But then I have the negative in front. What should I do to it? Reflect with respect to the x-axis. And then what do you want me to do next? So one more time, I start with x squared. You said 2 to your left, perfect. Then the minus in front will reflect. And then you want me to do what? Exactly. Give me the vertex. That's all I care. One more time. X squared, 2 to your left, reflect, up 4. What is the vertex? What is the x-coordinate of the vertex? Okay, let's do it again. X squared, 2 to your left. Where am I now? No, to your left. Good. I reflect, and then I go up 4. So what are the coordinates of the vertex then? Negative 2, comma. But I went up 4. Negative 2, comma. So the shape, part A, the leading coefficient is negative. It's a negative number, it's -1, so it will have a maximum. And the vertex is exactly what you gave me without any calculations. So if the quadratic function is given like this with completed square, you don't have to calculate the vertex. You only have to think. One more time, x squared, I go to the left 2, I'm at -2. I reflect at -2, and then -2 goes up to 4. So that's your vertex. Well, everything else has to be determined. So part C, we want the X-intercepts, if they exist. So for a maximum, these are the 3 possibilities. Exactly what we had with the other one, with the minimum. Nothing different, but it's a different shape. So let's analyze if it's the first case, the second case, or the third case. Because if it's the first case, I don't want to waste my time. I'll say they don't exist, and I'm done. Move on. Is it the first, is it the second, or is it the third? It is the second. How do I know? Because the maximum is +4. Can anyone give us the range already? We haven't graphed it yet, but can you come up with a range already? Range. From -infinity up till? There is a maximum at 4, right? So from -infinity to 4. We already know the range. Would you agree? Okay, so if they exist, how do I determine the X-intercepts if they exist? For any function. Very good. -x plus 2 squared plus 4 equals 0. First step, please. How do I solve this equation? Of course. Very good. Then, say it again. Very good. Excellent. Divide or multiply by -1. Now remember, I have 4 methods. I have taking square roots, I have completing the square, I have factoring, and I have the quadratic formula. Which one specifically has to be used now, for sure? Which one? Exactly. It's already exactly in that format. So x plus 2 equals plus or minus 2, or x equals -2 plus or minus 2, and I have to simplify them. So I get x equals -4 and x equals 0. So -4, 0, and 0, 0. There is no point in trying to find the y-intercept. It's the same. So D, the y-intercept, 0, 0. E and F. E was maximum. You already told me is 4. And axis of symmetry. Can anyone tell us the axis of symmetry? No, the axis of symmetry is a line, a vertical line passing through the vertex. So it's x equals -2. And the last one, the range. You already gave me the range. So here's the graph. We plot the vertex first. We graph the axis of symmetry. And then we have 0, 0, and 4, 0. And here's the graph. So this is f of x, -x plus 2 squared plus 4. Any questions?